Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this. 6,000 years before the first pyramid rose from Egyptian sands, something began moving toward us through the darkness between stars. While our ancestors were discovering fire and inventing the wheel, this cosmic wanderer drifted silently through the void, carrying secrets from another world entirely. Its journey would span the entire history of human civilization, OZCA, from the first scratches of cuneiform writing to the launch of the James Webb Space Telescope. And here's the thing that'll blow your mind. We had no idea it was coming. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Now, imagine being the person who first spotted this thing. July 1st, 2025, at exactly 3:47 a.m. Chilean time. The Atlas Survey Telescope in the Atacama Desert, ATLES, this incredible automated system that scans the sky every night looking for anything unusual, captured 4 tiny pixels of light that would change everything we thought we knew about our place in the universe. Dr. Sarah Chen was monitoring the automated detection system from her control room, probably sipping her 3rd cup of coffee of the night shift, when the computer flagged something that made her heart skip a beat. Object A11PL3Z was moving at what the system called impossible speed across the constellation Serpens. And here's where it gets wild. Within 6 hours, 3 independent observatories around the world confirmed what no one wanted to believe. We had a visitor from another star system, and this one was breaking all the rules. Think about that for a second. In the entire history of astronomy, we've only confirmed 3 interstellar visitors to our solar system. The first was Oumuamua in 2017. Weird, sure, but it behaved mostly like we expected. The second was Comet Borisov in 2019. IP. Pretty normal, honestly. But 3I, Atlas? This thing was different from the moment we laid eyes on it. The object blazed through space at 140,000 miles per hour. Let me put that in perspective for you. That's fast enough to fly from New York to Tokyo in 45 minutes. Your commercial jet takes about 14 hours to make that same trip. Unlike the previous interstellar visitors that crawled through our solar system like cosmic snails, this thing moved like it had somewhere important to be. But here's what really got the astronomy community buzzing. Remember, space is vast beyond imagination. When we say something is moving through empty space, we're talking about distances so huge that light itself takes years to travel between stars. For any object to maintain this kind of speed over interstellar distances requires either incredible natural forces or, well, something else entirely. Dr. Chen and her team realized they were watching something unprecedented unfold in real time. The discovery protocol for potentially hazardous objects is pretty straightforward. You detect, you confirm, you track, you categorize. But 3I Atlas was revealing characteristics that didn't fit any category they had. First, there was the brightness. Normal comets brighten predictably as they approach the sun because solar radiation heats up their icy surfaces, creating the classic glowing coma we associate with comets. 3I Atlas was definitely brightening, but the pattern was wrong. Instead of a smooth, gradual increase, it pulsed, like a cosmic heartbeat. Then came the trajectory analysis, and this is where things get really interesting. You see, when objects enter our solar system from interstellar space, they typically approach from random directions. Space is 3-dimensional, and there's no reason for an object from another star system to line up with anything in particular. It's like throwing a baseball randomly into a crowded stadium. The chances of it following any specific path are essentially zero. But 3I, Atlas, approached our solar system, aligned within 5 degrees of the ecliptic plane. That's the flat disk, where all our planets orbit. The probability of this happening by chance? 0.2%. Imagine throwing a dart from across a football field while blindfolded and hitting a quarter taped to the goalpost. That's the level of improbable precision we're talking about. Dr. James Liu at Caltech ran the numbers 3 times because he couldn't believe what he was seeing. It's like the object knew exactly where our planetary system was, he told his colleagues, like it was aiming for us. The speed differential told an even stranger story. Previous interstellar visitors Oumuamua and Comet Borisov had crawled through our neighborhood at 26 and 32 kilometers per second respectively. Those speeds made sense. They matched what computer models predicted for objects ejected from typical stellar systems. 3I, Atlas screamed past at 58 kilometers per second, nearly twice as fast as anything natural should move. Dr. Liu compared it to the difference between a leisurely bicycle ride and a Formula One race car at full throttle. But here's the detail that really kept astronomers up at night. The Hubble Space Telescope, with its incredible resolution, captured something that made everyone's blood run cold. Normal space rocks, asteroids, comets, chunks of debris, maintain steady rotation patterns once they're set spinning. Physics demands it. Conservation of angular momentum. These objects can spin for millions of years with clockwork regularity. 3I, Atlas was different. Hubble revealed the object spinning in a complex tumble that changed every few hours, as if something inside was actively adjusting its orientation. Picture a figure skater spinning, then suddenly changing their arm position to speed up or slow down their spin. Except this was happening in the vacuum of space, with no external forces to explain the changes. Dr. Elena Vasquez, the mathematician who first calculated the trajectory probabilities, spent sleepless nights trying to find a natural explanation. Dead rocks don't change their rotation, she kept telling her team. There has to be internal activity. Something is causing these changes from within. The Discovery team found themselves in uncharted territory. Every measurement, every observation, every analysis pointed toward the same uncomfortable conclusion. 3I, Atlas, exhibited characteristics that natural objects simply don't display. But the alternative explanation was almost too extraordinary to consider. Think about the timing for a moment. This object entered the outer boundaries of our solar system approximately 8,000 years ago, right around the time human civilization began developing advanced technologies and systematic record-keeping. The pyramids, written language, mathematics, astronomy, all emerging just as this cosmic visitor began its long approach toward the inner solar system. Was it coincidence? Dr. Vasquez calculated the probability of such perfect timing at less than 1%. In the scientific community, when multiple independent factors each have low probability and they all align perfectly, you start looking for connections rather than coincidences. The more they studied 3I Atlas, the more questions emerged. Why was it moving so fast? Why the perfect trajectory alignment? Why the changing rotation pattern? Why the unusual brightness variations? Each question led to more observations, and each observation deepened the mystery. By the end of July 2025, just 4 weeks after discovery, 3I Atlas had captured the attention of every major observatory on Earth. The European Southern Observatory allocated emergency observation time. NASA reprioritized Hubble's schedule. The James Webb Space Telescope turned its incredible infrared vision toward this mysterious visitor. But with each new observation, the object became more puzzling rather than less. The spectroscopic analysis revealed familiar materials: ice, water ice, carbon dioxide, basic organic compounds, BCSEA, but in combinations and concentrations that didn't match any known type of comet. It was like looking at a recipe that used familiar ingredients but produced something completely unprecedented. Dr. Chen, who had been the first to spot those 4 pixels of light, found herself at the center of the most significant astronomical discovery in decades. "We knew within hours that this was special," she later recalled, "but it took weeks to realize just how special 3I Atlas wasn't just unusual, it was challenging our fundamental understanding of how interstellar objects behave." The astronomy community began using a new phrase, anomalous characteristics. It was their polite way of saying, "This thing is doing stuff that shouldn't be possible." As summer turned to autumn, and 3I Atlas continued its approach toward the inner solar system, one truth became increasingly clear to everyone watching. Whatever this object was, wherever it came from, however it had traveled the vast distances between stars, it represented something entirely new in human experience. The silent visitor that had begun its journey when humans were just learning to write had finally arrived, and it was about to turn everything we thought we knew about our cosmic neighborhood completely upside down. Tomorrow, we'll dive into what happened when this cosmic rule-breaker started behaving in ways that made even the most experienced astronomers question the laws of physics themselves. Because what 3I Atlas did next would force humanity to confront a possibility that changed everything, the possibility that we might not be alone after all. Welcome back. I hope you're ready for this, because what I'm about to tell you is going to sound like science fiction, but every word of it is documented scientific fact. Picture a river flowing backward uphill, and you begin to understand how astronomers felt watching 3I Atlas behave. Comets follow predictable patterns established over 4 billion years of solar system evolution, but this visitor apparently never received the cosmic instruction manual. Now, before we dive into the weirdness, let me give you the basics of how comets are supposed to work. It's actually pretty simple and beautiful. A comet is essentially a dirty snowball, a chunk of ice, rock, and organic compounds left over from the formation of some star system. When it gets close enough to a star, solar radiation heats up the surface, causing the ice to sublimate directly from solid to gas. This creates a glowing cloud called a coma around the nucleus, and solar wind pushes this material away from the star, forming the classic tale we all know and love. The key word there is away. Solar wind always pushes material away from the star. Always. It's like standing in front of a giant hairdryer. The airflow pushes everything in the same direction. This is one of the most fundamental, reliable principles in astronomy. 3I Atlas looked at this principle and said, "Nah, I'm good." Dr. Michael Torres at the European Southern Observatory was the first to notice what he initially thought was a data error. The spectroscopic readings showed material streaming toward the sun, not away from it. He ran the analysis 3 times, checked his instruments, even called a colleague at 2 a.m. to verify his calculations. It was like watching a waterfall flow upward. He later described to the International Astronomy Conference, "I've been studying comets for 23 years, and I've never seen anything like it. This wasn't just unusual, it was physically impossible, according to everything we knew about how solar wind interacts with cometary material." The phenomenon became known as the anti-tail, or sunward jet, and it had theoretical physicists working overtime trying to figure out how it could exist. Dr. Sarah Kim at MIT proposed that maybe 3I Atlas had some kind of unusual magnetic field that could deflect solar wind. But the energy requirements for such a field would be enormous, far beyond what any natural magnetic process could generate in a small object. Others suggested perhaps the object was rotating so rapidly that centrifugal force was launching material in all directions. But the Hubble observations showed the sunward jet was highly directional and sustained, not the random spray you'd expect from rapid rotation. Here's where it gets really wild. The antitail wasn't constant. It pulsed. Every 4 hours and 17 minutes, like clockwork, the intensity would increase dramatically for exactly 17 minutes, then return to baseline. Think about that. What natural process creates such precise timing? Even our most accurate atomic clocks don't maintain that kind of consistency without constant adjustment. But the antitail was just the beginning. Remember that trajectory analysis I mentioned yesterday? Well, mathematician Dr. Elena Vasquez spent weeks double-checking her calculations because she couldn't believe what the numbers were telling her. 3. I, Atlas, approached our solar system, aligned within 5 degrees of the ecliptic plane. I, the flat disk where all our planets orbit. Now, here's why this is so mind-blowing. Imagine our solar system as a dinner plate floating in a vast ocean. An object from another star system is like a fish swimming randomly through that ocean. The chances of that fish happening to swim parallel to the dinner plate, rather than approaching from above or below or any other random angle, is vanishingly small. Dr. Vasquez calculated the probability, 0.2%. To put that in perspective, you're more likely to get struck by lightning twice in the same day. It's like throwing a dart from across a football field while blindfolded and hitting a quarter taped to the goalpost. That level of improbable precision. Either we're witnessing the most extraordinary coincidence in astronomical history, Dr. Vasquez told her team, or this object's trajectory was deliberately planned. The speed differential told an even stranger story. Previous interstellar visitors, Oumuamua and Comet Borisov, had crawled through our neighborhood at 26 and 32 kilometers per second respectively. Those speeds made perfect sense based on computer models of how objects get ejected from typical stellar systems. 3I, Atlas, screamed past at 58 kilometers per second, nearly twice as fast as anything natural should move. Dr. James Liu at Caltech compared it to the difference between a leisurely bicycle ride and a Formula One race car at full throttle. But here's what kept everyone up at night. That speed was almost exactly what you'd need for optimal interstellar travel. Too slow, and the journey between stars takes millions of years. Too fast, and you waste enormous amounts of energy. 58 kilometers per second sits right in the sweet spot for efficient interstellar transit. It's like someone calculated the most energy-efficient speed for traveling between star systems, Dr. Liu observed, and that's exactly how fast this thing is moving. The rotation pattern provided perhaps the most unsettling evidence that something was seriously wrong with our understanding of 3I Atlas. The Hubble Space Telescope, with its incredible resolution, revealed the object spinning in a complex tumble that changed every few hours. Here's why this is so significant. Normal space rocks, asteroids, comets, chunks of debris maintain steady rotation patterns once they're set spinning. It's basic physics. Conservation of angular momentum. Think of a figure skater spinning with their arms extended, then pulling their arms in to spin faster. Once they choose a position, they maintain that spin rate until something external changes it. In the vacuum of space, there are no external forces to change an object's rotation. No air resistance, no friction. Objects can spin for millions of years with clockwork regularity. The asteroid Eros, for example, has maintained the same rotation period for at least 10,000 years. 3I Atlas was different, really different. The object seemed to be constantly fine-tuning its attitude, like a spacecraft making tiny adjustments to its orientation. Every few hours, the rotation would change slightly, sometimes speeding up, sometimes slowing down, sometimes shifting its axis entirely. Dr. Jennifer Walsh at the Space Telescope Science Institute spent months analyzing the rotation data. Dead rocks don't change their spin. She kept telling anyone who would listen, there has to be internal activity. Something inside this object is causing these changes. The changes weren't random either. They followed patterns that suggested active control rather than natural processes. It was like watching a gymnast in slow motion, constantly adjusting their position to maintain perfect balance. Then came the brightness variations, and this is where things got really spooky. Normal comets brighten predictably as they approach the sun because solar radiation heats up their surfaces, causing more ice to sublimate and creating a bigger, brighter coma. It's a smooth, gradual process that follows well-understood physics. 3I, Atlas, pulsed like a cosmic lighthouse. The brightness would surge by 30% for exactly 17 minutes, the same duration as the anti-tail pulses, then fade back to normal. This happened with the same 4-hour and 17-minute regularity. Dr. Mark Stevens at the Jet Propulsion Laboratory ran computer simulations trying to find a natural explanation for such precise timing. Solar heating couldn't explain it. Sun's energy output is too constant. Internal radioactive decay couldn't explain it. That process is random, not rhythmic. Rotational effects couldn't explain it. The brightness pulses didn't match the rotation period. We're looking at behavior that requires some kind of internal timing mechanism. Dr. Stevens concluded. Something is controlling these pulses from within the object. The spectroscopic analysis added another layer of mystery. 3I, Atlas showed all the expected signatures of a comet: water vapor, carbon dioxide, carbon monoxide, even trace amounts of organic compounds. But the ratios were wrong, way wrong. Normal comets from our solar system have water to carbon dioxide ratios that fall within a predictable range based on where they formed and how long they've been orbiting. It's like a fingerprint that tells us about the comet's origin and history. 3I, Atlas had ratios that didn't match anything in our databases. The water content was too low, the carbon dioxide too high, and there were trace elements that shouldn't exist in significant quantities in any natural comet. Iron, nickel, even rare earth elements typically found only in the cores of rocky planets. Dr. Lisa Park at the Harvard-Smithsonian Center for Astrophysics described it as looking at a recipe that used familiar ingredients but produced something completely unprecedented. It's like finding a cake that contains flour, eggs, and sugar, but also titanium and platinum. By September 2025, 3 months after discovery, 3I Atlas had accumulated so many anomalous characteristics that astronomers started using a new classification: unidentified interstellar object. It was their polite way of saying, "We have no idea what this thing is." The European Space Agency convened an emergency panel to review all the observational data. NASA established a dedicated task force. The International Astronomical Union created a new working group specifically for anomalous interstellar objects. But despite all the attention, all the analysis, all the computer modeling, one uncomfortable truth was becoming increasingly clear. 3I, Atlas was behaving like no natural object should behave. And that's when Dr. Abraham Loeb decided to say what everyone was thinking, but no one wanted to voice. What if 3I, Atlas, wasn't natural at all? Tomorrow, we'll explore how one of Harvard's most respected astrophysicists risked his entire career to suggest that humanity might be looking at its first confirmed example of extraterrestrial technology, and why his analysis would send shockwaves through the scientific community and beyond. Welcome back. Today we're diving into one of the most controversial moments in modern astronomy, when a respected Harvard professor looked at all the evidence we discussed yesterday and came to a conclusion that would shake the scientific world to its core. Into this growing scientific chaos stepped Dr. Abraham Loeb, Harvard University's most controversial astrophysicist, and the man who had already suggested that Oumuamua might be alien technology. But where other astronomers saw inexplicable anomalies, Loeb saw patterns that pointed towards something almost unthinkable: artificial origin. Now, you have to understand something about Avi Loeb. This isn't some fringe researcher working out of a basement. We're talking about the former chair of Harvard's astronomy department, former director of the Institute for Theory and Computation, former chair of the Board on Physics and Astronomy of the National Academies. This is a guy with over 700 peer-reviewed papers and a reputation built over decades of groundbreaking research. When Loeb speaks, the astronomy community listens. They might not always like what he says, but they listen. Working 18-hour days from his Cambridge office that September, surrounded by whiteboards covered in equations and probability calculations, Loeb developed what would become known as the Technological Assessment Scale, a quantitative framework for evaluating whether astronomical objects might be artificial. Think about this for a moment. Until 3I, Atlas, no one had ever needed such a framework. The idea that we might encounter artificial objects from other star systems was pure science fiction. But here was one of the world's most respected astrophysicists creating mathematical tools to evaluate exactly that possibility. The scale used 8 specific criteria, including trajectory optimization, geometric properties, temporal correlations, and energy signatures. Each criterion was scored from 0 to 10, with 10 representing clear evidence of technological origin. Most natural objects score 0 or 1 across all categories. Loeb assigned 3I, Atlas, a total score of 4 out of 10 possible points for technological origin. That might not sound like much, but in the context of astronomical objects, it was unprecedented. No natural object had ever scored above 1 on any previous evaluation. Here's what pushed 3I Atlas into this uncharted territory. First, the trajectory optimization we talked about yesterday. The object's path through our solar system wasn't just improbable, it was optimal. If you wanted to design a route that provided the best observation opportunities for every major planet while remaining difficult to detect until the final approach phase, you'd choose exactly the path 3I Atlas was following. It's like someone calculated the most efficient reconnaissance trajectory, Loeb explained to his colleagues, and executed it with mathematical precision. The timing correlation proved especially disturbing. 3I Atlas had entered the outer boundaries of our solar system approximately 8,000 years ago, precisely when human civilization began developing advanced technologies and systematic record-keeping. Writing systems, mathematics, astronomy, metallurgy, all emerging just as this cosmic visitor began its long approach toward the inner solar system. Loeb calculated this coincidence carried less than 1% probability of occurring naturally. In science, he noted, when multiple independent factors each have low probability and they all align perfectly, you start looking for connections rather than coincidences. But the most chilling aspect of Loeb's analysis centered on something called the dark forest scenario. It's based on a solution to the Fermi paradox, AG, the question of why, in a universe that should be teeming with intelligent life, we haven't found any evidence of it. The dark forest hypothesis suggests that intelligent civilizations stay hidden because the universe contains cosmic predators. Any species that reveals its location risks destruction by more advanced civilizations that view other intelligences as threats to be eliminated. It's like a vast cosmic game of hide and seek, where getting found means getting destroyed. If 3I Atlas represented a probe from such a civilization, its behavior made perfect sense. Arrive during humanity's technological infancy, when we're advanced enough to be interesting but not advanced enough to be threatening. Observe from optimal distances. Remain difficult to detect until the very end of the mission. The object's characteristics suggest reconnaissance rather than accident, Loeb wrote in his preliminary analysis. If this is a probe from a hostile intelligence, we're looking at a perfectly executed surveillance mission. Now, I want to be clear about something. Loeb wasn't saying, this is definitely alien technology. What he was saying was, the evidence suggests we need to seriously consider this possibility. That's a crucial distinction that got lost in much of the media coverage that followed. His September paper, titled Anomalous Characteristics of the Interstellar Object, 3I Atlas, a preliminary assessment of technological origin, sent shockwaves through the astronomical community that are still reverberating today. Dr. Sarah Lawler at the University of Regina called his conclusions dangerous speculation that undermines serious scientific discourse. Dr. Darrell Seligman at Michigan State dismissed them as insulting to the intelligence of the scientific community. The criticism was swift, harsh, and personal. But here's what made the controversy so intense. Behind closed doors, even skeptical astronomers admitted that Loeb's mathematical analysis was flawless. They might not like his conclusions, but they couldn't find errors in his methodology or calculations. Dr. Elena Rodriguez at the Arecibo Observatory captured the dilemma perfectly. Harvey's math is bulletproof. His logic is sound. It's just that his conclusion is so extraordinary that it requires extraordinary evidence, and we're not sure we have that yet. The extraordinary evidence question became the central battleground. Critics argued that unusual didn't necessarily mean artificial, that natural processes we don't yet understand could explain 3I Atlas's behavior. Supporters countered that dismissing the artificial hypothesis without investigation was itself unscientific. Loeb pressed forward with additional analysis that only deepened the mystery. The object's rotation changes, he demonstrated, followed patterns consistent with active attitude control. Yes, the kind of constant micro-adjustment spacecraft make to maintain optimal orientation. The brightness pulses matched the timing signature of regulated energy output rather than random natural processes. Most significantly, he identified what he called optimization markers, characteristics that suggested the object was designed for efficiency rather than shaped by random natural forces. The speed was optimal for interstellar travel. The trajectory was optimal for solar system reconnaissance. Even the rotation pattern was optimal for maintaining communication with multiple distant points. We're seeing too many optimization markers for this to be coincidental, Loeb argued. Natural selection doesn't work in empty space. Only intelligent design creates such systematic optimization. The controversy exploded into public view when Loeb published a blog post warning that if 3I Atlas proved artificial, humanity lacked any established protocols for responding to active alien technology near Earth. We're like children playing in a cosmic playground, he wrote, completely unaware that we might not be alone on the swings. We have detailed plans for asteroid impacts, solar flares, even nuclear war, but we have no framework for dealing with the discovery of extraterrestrial intelligence actively studying our planet. The blog post went viral within hours. News organizations worldwide picked up the story. Social media exploded with debates about alien visitors and government cover-ups. Suddenly, 3I Atlas wasn't just an astronomical curiosity, it was a potential paradigm shift that forced humanity to confront its place in the universe. But the real earthquake was yet to come. As October arrived and 3I Atlas continued its approach toward perihelion, ATL, its closest point to the Sun, Loeb made a prediction that would prove to be either the most brilliant insight in astronomical history or the most bland, spectacular mistake of his career. He predicted that if 3I Atlas was indeed artificial, it would perform a specific maneuver during perihelion, a reverse Oberth burn, that would use solar gravity to amplify artificial propulsion, allowing the object to dramatically change course with minimal energy expenditure. If this object is a probe, he wrote, perihelion is when it will reveal its true nature. The physics of orbital mechanics make this the optimal moment for any course correction. If we see a maneuver, we'll know we're not alone. The prediction was precise, testable, and terrifying, because if Loeb was right, humanity was about to witness the SPLY, first confirmed example of extraterrestrial technology operating in our solar system. And if he was wrong, well, his career would probably never recover from the controversy. Either way, October 29th, 2025, El Perihelion Day, would determine whether humanity lived in a universe of cosmic coincidences or deliberate visitors. Tomorrow, we'll explore how the world responded to Loeb's extraordinary claims and why the United Nations made an unprecedented decision that would change planetary defense forever. Hey there! Hope you're ready for this next part, because what happened next shows just how seriously the world's governments took Loeb's warnings about 3I Atlas. October 21st, 2025, became the date when humanity officially acknowledged it might not be alone. The International Asteroid Warning Network, a United Nations-endorsed organization that had spent 15 years tracking routine space rocks, made an announcement that would have been unthinkable just months earlier. For the first time in history, they would target an interstellar object for dedicated planetary defense monitoring. Let me give you some context here. The International Asteroid Warning Network, or IAWN, was established in 2010 after astronomers realized we had a serious blind spot in our planetary defense capabilities. We were pretty good at finding big asteroids that might hit Earth years or decades in advance, but we had no coordinated system for tracking fast-moving objects that might give us only weeks or months of warning. IAWN was designed to be the early warning system for asteroid impacts. Their job was to detect, track, and coordinate global responses to space rocks that might pose a threat to Earth. In 15 years of operation, they had never, not once, designated anything other than garden-variety asteroids and comets for monitoring. 3I Atlas changed all that. The decision emerged from 48 hours of emergency. Consultations spanning 6 continents. I've seen some of the declassified transcripts from those meetings, and let me tell you, the level of concern was unlike anything these organizations had ever dealt with. Dr. Detlef Koschny, head of the European Space Agency's Space Situational Awareness Program, described the situation as unlike anything we've ever faced. Unlike asteroids that follow predictable orbits calculated centuries in advance, 3I Atlas represented what military analysts call an unknown capability with potentially hostile intent. Think about that phrase for a moment. Military analysts. We're not talking about astronomers anymore. We're talking about people whose job it is to assess threats to national security, and they were using the same language they'd use for an unidentified aircraft entering restricted airspace. The announcement itself was carefully worded, but if you knew how to read between the lines, it was absolutely extraordinary. IAWN stated that 3I Atlas exhibited anomalous characteristics requiring enhanced monitoring protocols and represented unique challenges for trajectory prediction and threat assessment. In diplomatic speak, that translates to, "This thing is doing stuff we don't understand, and we're not sure if it's dangerous." Within 72 hours of the announcement, the most sophisticated space surveillance network ever assembled locked onto the mysterious visitor. The scale of the operation was breathtaking. 23 major observatories, 4 space-based telescopes, and 3 planetary radar systems, all coordinated through a new rapid response protocol developed specifically for anomalous objects. NASA's Deep Space Network in California, Spain, and Australia began continuous monitoring, creating the first real-time tracking system ever deployed for an interstellar visitor. These are the same dishes that communicate with Voyager spacecraft on the edge of the solar system, now repurposed to watch a single, object that might or might not be artificial. The James Webb Space Telescope, humanity's most advanced astronomical instrument, allocated emergency observation time, normally reserved for critical mission operations. This is a telescope so in demand that astronomers compete for observation time years in advance. Projects worth millions of dollars were delayed to keep JWST's instruments trained on 3I Atlas. Hubble Space Telescope adjusted its pointing schedule, dedicating over 60% of its observation time to monitoring the object's brightness variations and rotation changes. Ground-based giants like the Very Large Telescope in Chile and the twin Keck Observatory telescopes in Hawaii joined the global watch. Dr. Amy Chen, coordinating the effort from NASA's Jet Propulsion Laboratory, found herself managing data streams from instruments worth over $12 billion, all focused on a single object no larger than a city block. Every 6 hours, observatories worldwide transmitted measurements to a central analysis center where supercomputers process trajectory data, spectroscopic readings, and photometric observations. We've essentially created a global telescope network with Earth-sized aperture, Dr. Chen explained to her team. If 3I Atlas sneezes, we'll detect it. The operation's complexity was staggering. Different telescopes observe in different wavelengths: optical, infrared, radio, ultraviolet. Each provides unique information about the object's composition, temperature, magnetic field, and activity level. Coordinating observations across multiple time zones, weather patterns, and technical specifications required logistics normally reserved for military operations. But the real challenge wasn't technical, it was political. How do you tell the world's governments that you're using billions of dollars worth of scientific equipment to monitor something that might be an alien probe without causing mass panic? The answer was carefully a managed information flow, technical briefings for world leaders, regular updates to space agencies, scientific papers that discussed anomalous characteristics without mentioning the possibility of artificial origin, at least not officially. Military implications added another layer of complexity that most people never realized. 3I Atlas moved too fast for conventional deflection methods. Traditional planetary defense assumes years or decades of warning time to mount a response. Nuclear-tipped interceptors, gravitational tractors, kinetic impactors, EEs, all the technologies we've developed for asteroid defense require long lead times. 3I Atlas compressed those warning times from years to weeks. If the object changed course toward Earth, there would be no time to mount a traditional planetary defense response. The object's speed made it essentially unstoppable by any technology we currently possess. Defense planners had to consider scenarios they had hoped never to face. What if 3I Atlas wasn't just a probe, but a weapons platform? What if it deployed smaller objects toward Earth? What if it was the advanced scout for a larger force? Dr. General Patricia Williams, Director of the U.S. Space Force's Space Domain Awareness Program, put it bluntly in a classified briefing. If this thing is hostile and decides to do something aggressive, our current defensive capabilities are essentially zero. We'd be trying to stop a bullet with a butterfly net. The psychological pressure on the monitoring teams was immense. These were scientists trained to study distant galaxies and exotic phenomena, now tasked with potentially detecting the first signs of extraterrestrial intelligence. Some team members reported insomnia, anxiety, even panic attacks as the implications of their work sank in. Dr. Jennifer Walsh at the Space Telescope Science Institute captured the mood perfectly. Every data point we collect might be the one that confirms we're not alone in the universe. Every observation might be the moment that changes human history forever. The responsibility is overwhelming. Meanwhile, public interest reached fever pitch. Loeb's blog posts were shared millions of times. Amateur astronomers worldwide pointed their telescopes at 3I Atlas, hoping to capture their own evidence of anomalous behavior. Conspiracy theories proliferated on social media. Government denials only fueled speculation about cover-ups and secret knowledge. The monitoring campaign also revealed something unexpected about international cooperation. Despite political tensions, trade wars, and territorial disputes, the 3I Atlas situation brought together scientists and governments in unprecedented collaboration. Data was shared instantly across national boundaries. Observation schedules were coordinated between countries that barely spoke to each other diplomatically. Dr. Elena Rodriguez at Arecibo Observatory noted the irony. It took the possibility of alien visitors to get humanity working together like we should have been all along. As October progressed and perihelion approached, the monitoring network detected changes in 3I Atlas that made everyone extremely nervous. The object's activity level was increasing. Radio emissions were becoming more frequent and structured. The brightness pulses were intensifying. Most concerning were the equipment failures. Observatories worldwide reported technical problems at rates 5 times normal whenever they pointed their instruments at 3I Atlas. Radio telescopes experienced mysterious interference. Spacecraft in the outer solar system reported communication blackouts that coincided exactly with the object's radio emissions. Dr. Mark Stevens at JPL summarized the situation in terms that made everyone's blood run cold. Either we're seeing the most extraordinary sequence of coincidences in scientific history, or this object is actively interfering with our observation attempts. Neither possibility is comforting. By October 25th, just 4 days before perihelion, the Global Monitoring Network had collected more data on a single astronomical object than any previous scientific endeavor. Thousands of hours of observation time, petabytes of data, hundreds of researchers working around the clock. And all that data pointed toward the same unsettling conclusion. 3I Atlas was behaving like no natural object should behave. The stage was set for October 29th, AIO Perihelion Day, when Loeb's predictions would either be vindicated or shattered. The entire world would be watching as 3I Atlas reached its closest approach to the Sunday. Tomorrow, we'll experience those final, terrifying hours as humanity held its breath, waiting to learn whether we shared the universe with intelligences beyond our comprehension. Welcome back. I hope you're sitting down for this one, because what happened in the final days before perihelion would test every assumption humanity had about our place in the universe. October 29th, 2025, Perihelion Day. Every astronomer on Earth had this date circled on their calendar, knowing it would determine whether humanity lived in a universe of cosmic coincidences or deliberate visitors. But let me explain why this date was so crucial, because the physics here are absolutely fascinating. Perihelion represents the moment when any space traveler would logically make its move. The science is inescapable. An object's closest approach to the Sun offers maximum gravitational acceleration for any course correction. Think of it like a cosmic slingshot. When you're moving past a massive object like the Sun, you can use its gravity to dramatically change your speed and direction with minimal energy expenditure. It's called an Oberth maneuver, named after the German rocket pioneer Hermann Oberth, and it's one of the most efficient ways to travel through space. If 3I Atlas carried propulsion systems, perihelion was when they would fire. The maneuver would be hidden from Earth-based observation because the Sun would block our view, a perfect cover for a clandestine operation. Dr. Avi Loeb had identified the specific signature to watch for, a reverse Oberth maneuver that would use solar gravity to amplify any artificial acceleration. The technique could multiply the effect of onboard propulsion by factors of 10 or more, allowing a small spacecraft to achieve dramatic velocity changes with minimal fuel expenditure. If this object is artificial, Loeb had predicted, perihelion is when it will reveal its true nature. The physics of orbital mechanics make this the optimal moment for any course correction. 3 days before perihelion, 3I, Atlas began displaying activity that made every scientist monitoring it extremely nervous. The first sign came from the Atacama Large Millimeter Array in Chile, ALMA, the most sensitive radio telescope array ever built. Dr. Carlos Martinez was reviewing the overnight data when he noticed something that made him call his supervisor at 4 in the morning. ALMA had detected sudden bursts of radio emission from 3I Atlas, lasting exactly 17 minutes. These weren't the random radio waves that many cosmic objects emit. These were structured, organized, clearly artificial signals. The signal structure was unlike anything we'd ever detected from a natural source, Dr. Martinez later testified to a UN panel. It showed frequency modulation, amplitude control, even what appeared to be error correction encoding. This was clearly technological in origin. The emissions repeated every 4 hours and 12 minutes with clockwork precision. Think about that. What natural process creates such exact timing? Even our most accurate atomic clocks require constant adjustment to maintain that kind of consistency. Dr. Sarah Kim at MIT ran the timing through every known natural phenomenon: IS, pulsar rotation, stellar oscillation, magnetic field variations. Nothing matched the precise 4-hour, 12-minute cycle. We're looking at behavior that requires some kind of internal timing mechanism, she concluded. Something is controlling these emissions from within the object. But the radio signals were just the beginning. Hubble's high-resolution cameras captured images that made everyone question what they were seeing. The object's coma, the glowing cloud of gas and dust around its nucleus, was brightening and dimming in synchronized pulses that matched the radio emissions exactly. Dr. Jennifer Walsh at the Space Telescope Science Institute spent sleepless nights analyzing the brightness variations. The pattern resembled a cosmic lighthouse, she described to the emergency response team. Intensity variations that followed mathematical sequences rather than random fluctuations. Normal comets brighten and fade based on solar heating, rotation, and outgassing. The changes are gradual, predictable, and follow well-understood physics. 3I, Atlas was pulsing like a beacon, with brightness changes that corresponded to the 17-minute radio bursts. We're seeing coordinated activity across multiple systems. Dr. Walsh reported, radio emissions, optical brightness, spectral changes, all synchronized with mathematical precision. Natural objects don't exhibit this level of systematic coordination. Most dramatic were the spectroscopic changes observed by the Very Large Telescope in Chile. Chemical emissions from 3I Atlas shifted dramatically over just 48 hours, with carbon monoxide levels increasing by 300%, while water vapor decreased proportionally. Dr. Lisa Park at Harvard-Smithsonian had never seen anything like it. Natural sublimation, ES, the process by which comet ice turns directly to gas, couldn't explain such rapid, coordinated changes in multiple chemical species. It's like watching a chemical factory change its production profile in real time, she explained to the monitoring team. We're seeing deliberate adjustments in gas production that suggest active control over the sublimation process. The changes weren't random either. They followed patterns that suggested optimization, unsaid, maximizing certain emissions while minimizing others, as if the object was fine-tuning its chemical signature for specific purposes. As perihelion approached, observatories worldwide reported equipment failures at rates that stretched the definition of coincidence. Radio telescopes experienced mysterious interference that cleared up only when they stopped pointing at 3I Atlas. Optical telescopes suffered focusing problems that occurred exclusively during 3I Atlas observations. 3 separate spacecraft monitoring the object: the Parker Solar Probe, Solar Orbiter, and Stereo A, reported temporary communication blackouts lasting exactly the same 17-minute intervals as the radio emissions. Dr. Elena Rodriguez at Mission Control struggled to find explanations. The spacecraft are in different locations, using different communication frequencies, operated by different agencies. There's no natural phenomenon that should affect all three simultaneously with such precise timing. The interference patterns suggested 3I. Atlas was actively jamming Earth-based observations. Each time monitoring equipment approached optimal sensitivity, something would interfere with the signals. It was like trying to photograph someone who kept covering the camera lens every time you focused. October 27th brought the development that convinced even the skeptics that something unprecedented was happening. The James Webb Space Telescope, monitoring 3I, Atlas in infrared wavelengths, detected thermal emissions that violated everything we knew about comet behavior. Normal comets heat up as they approach the Sun, reaching maximum temperature at perihelion. The heating is gradual and predictable, based on distance and solar radiation. JWST showed 3I, Atlas generating heat in specific patterns that had nothing to do with solar heating. "We're seeing controlled thermal emissions," reported Dr. Michael Chen, JWST's principal investigator. "Areas of the object heating and cooling independently of solar radiation. This suggests internal heat sources operating under some kind of programmed control. The thermal patterns match the radio emission timing, 17-minute heating cycles every 4 hours and 12 minutes. Whatever was generating the radio signals was also producing precisely controlled heat." October 28th, Haros Trey, just 24 hours before perihelion, brought the development no one had anticipated. Other objects began appearing near 3I, Atlas. The first detection came from the Subaru telescope in Hawaii. Dr. Yuki Tanaka was conducting routine monitoring when she noticed small, fast-moving objects separating from the main body of 3I, Atlas. "At first, I thought they were chunks of debris," she later recalled, "but their movements were too organized, too purposeful. These objects were maneuvering independently. Within hours, observatories worldwide confirmed the detections. Small objects, each roughly the size of a school bus, were detaching from 3I, Atlas like cosmic seeds dispersing in the solar wind. The separation process was clearly controlled. Each object emerged from the main body, oriented itself using brief thruster burns, then set course for different regions of the solar system. It was like watching a spacecraft deploy multiple probes, each programmed for a specific mission. Dr. Amy Chen at JPL coordinated tracking efforts as more objects appeared. By the end of October 28th, 17 separate objects had detached from 3I, Atlas, each following a precisely calculated trajectory. "We're witnessing a controlled deployment sequence," she reported to the emergency response team. "Each object is heading toward a different destination with mathematical precision. This is not natural fragmentation. This is deliberate separation." 3 objects adjusted course toward Mars. 2 others set trajectories for Jupiter's moon Europa. 4 more aimed for the asteroid belt between Mars and Jupiter. But 8 objects demonstrated the most unsettling behavior of all. They established orbits designed for long-term Earth observation. These Earth-directed objects positioned themselves at gravitationally stable points, where they could monitor our planet indefinitely. The L4 and L5 Lagrange points, L4, regions ahead of and behind Earth's orbit, where gravitational forces balance perfectly, allowing objects to maintain position with minimal energy expenditure. "It's like setting up permanent observation posts," Dr. Chen realized with growing alarm. "These objects are positioning themselves for long-term surveillance of Earth." The final hours before perihelion brought a development that confirmed everyone's worst fears. The radio emissions from 3I, Atlas, changed from simple pulses to complex structured transmissions containing mathematical patterns that defied natural explanation. Dr. Elena Rodriguez at Arecibo Observatory led the team analyzing the signals. We're seeing prime number sequences, mathematical constants, even what appears to be navigation data encoded in base 16 mathematics. This level of complexity requires technological intelligence to generate. The transmissions appeared to be directed toward specific star systems: Wolf 359, Gliese 667, HD 16459, 5, HD, all known to harbor potentially habitable planets. The object is reporting to multiple destinations, Dr. Rodriguez concluded. We're intercepting communication between 3I, Atlas, and intelligences in other star systems. As 3I, Atlas disappeared behind the Sun on October 29th, beginning the crucial perihelion phase hidden from Earth's view, one truth had become inescapable to everyone monitoring the situation. Humanity was no longer alone. Tomorrow, we'll witness what happened during those terrifying hours when 3I, Atlas, reached closest approach to the Sun, and how the revelation that followed would change human civilization forever. Welcome back to what might be the most important chapter in this entire story. What I'm about to tell you happened during a few crucial hours that would rewrite every astronomy textbook and force humanity to confront its place in a universe far stranger than anyone had imagined. October 29th, 2025 began like any other day for most of the world. People went to work, attended school, lived their normal lives, completely unaware that in a few hours everything we thought we knew about our cosmic neighborhood would change forever. As 3I, Atlas, reached closest approach to the Sun, hidden from Earth's view behind our star's blazing disk, the cascade of events that Dr. Avi Loeb had predicted became reality in ways that exceeded even his most extraordinary hypotheses. The James Webb Space Telescope, positioned at the L2 Lagrange point about 1 million miles from Earth in the opposite direction from the Sun, had an unobstructed view of what happened next. What JWST captured would become the most significant astronomical observation in human history. At exactly 14 hours, 37 minutes, and 12 seconds, universal time, as 3I, Atlas, reached its point of closest approach to the Sun, the 17 small objects we'd seen separating the day before didn't simply drift away from the main body. They maneuvered. Dr. Michael Chen, JWST's principal investigator, was monitoring the real-time data feed when he saw something that made him call every major observatory on Earth. "The objects are executing powered flight," he announced over the emergency communication network. "We have confirmed artificial propulsion." Each of the 17 objects fired thrusters in precisely coordinated sequences, accelerating away from 3I, Atlas, in different directions with mathematical efficiency that no natural process could achieve. It was like watching a choreographed ballet performed in the vacuum of space. The coordination was perfect. Dr. Chen later testified to a UN emergency session. Each object knew exactly when to fire its engines, for exactly how long, to achieve precisely the trajectory required for its individual mission. This level of coordination requires artificial intelligence far beyond anything humanity has achieved. 3 objects adjusted course toward Mars, using gravity-assisted trajectories that would bring them to the red planet within days. The precision was breathtaking. Each probe would arrive at Mars within hours of NASA's Perseverance rover, suggesting they were specifically targeting our robotic presence there. 2 others set trajectories for Jupiter's moon Europa, the icy world that likely harbors a subsurface ocean and represents our best hope for finding life within our solar system. These probes would reach Europa in perfect position to study the moon's south polar region, where geysers of water vapor suggest direct access to the hidden ocean below. 4 more objects aimed for the asteroid belt between Mars and Jupiter, but their trajectories weren't random. Each targeted a different region of the belt, suggesting a systematic survey of the rocky debris left over from our solar system's formation. But the 8 remaining objects demonstrated the most unsettling behavior of all. They established orbits designed for long-term Earth observation, positioning themselves at gravitationally stable points where they could monitor our planet indefinitely. These Earth-monitoring probes moved to the L4 and L5 Lagrange points, gravitationally stable regions 60 degrees ahead of and behind Earth's orbit. From these positions, they would have permanent, unobstructed views of our planet, while remaining virtually invisible to ground-based detection. It's the perfect surveillance. Constellation, realized Dr. Patricia Williams, director of the U.S. Space Force's Space Domain Awareness Program. From those positions, they can monitor everything: our communication satellites, space stations, military activities, even individual cities. We're under permanent observation. The main body of 3I, Atlas, executed the maneuver exactly as Loeb had predicted, but the reality exceeded even his most ambitious calculations. Using solar gravity to amplify artificial propulsion, the object performed a series of course corrections that demonstrated capabilities far beyond anything humans had achieved. The physics were staggering. 3I, Atlas, accelerated from 58 kilometers per second to 84 kilometers per second in just 6 hours. That's an increase of 26 kilometers per second, enough to escape Earth's gravity well from a standing start. The energy requirements for such acceleration were enormous, suggesting either revolutionary propulsion technology or fuel reserves that dwarfed anything we could imagine. We're looking at propulsion capabilities that are probably centuries ahead of our current technology, Dr. Elena Rodriguez calculated from Arecibo Observatory. The energy density required for those maneuvers exceeds our best chemical rockets by factors of hundreds. But the most significant revelation came from the signals 3I, Atlas, transmitted as it departed the inner solar system. Radio telescopes worldwide detected a burst of structured communications lasting exactly 4 hours and containing mathematical patterns that left no doubt about their artificial origin. Dr. Rodriguez led the team analyzing these transmissions, and what they found was simultaneously fascinating and terrifying. The signal structure included prime number sequences, mathematical constants, star charts showing nearby stellar systems, and what appeared to be navigation data encoded in base 16 mathematics, she reported to an emergency UN session. The transmissions were clearly directed towards specific star systems: Wolf 359, Gliese 667, HD 164595, and 12 other nearby stars known to harbor potentially habitable planets. But the signals weren't random broadcasts. They showed evidence of real-time communication protocols, as if 3I Atlas was actively conversing with intelligences at those distant locations. "We're intercepting progress reports," Dr. Rodriguez concluded with chilling certainty. "This probe is communicating with its controllers, providing updates on its mission status and observational data." The departure signals also contained something that made everyone's blood run cold: detailed information about Earth. Atmospheric composition, orbital characteristics, electromagnetic spectrum analysis of our major cities, even what appeared to be population density maps based on heat signature analysis. "The probe has been studying us far more thoroughly than we initially realized," Dr. Michael Torres at the European Southern Observatory reported. "These signals contain comprehensive intelligence about Earth's biosphere, technology level, and civilization distribution. Within hours of the perihelion maneuvers, every major government on Earth activated emergency protocols that most people didn't even know existed. The United States established the Department of Cosmic Security under direct presidential authority. China launched the Interstellar Monitoring Initiative with unlimited funding. The European Union created the Extraterrestrial Intelligence Response Center. Russia activated the Strategic Space Defense Command. The speed of governmental response revealed something that shocked many observers. World leaders had been preparing for this possibility far longer than anyone realized. Classified protocols existed for exactly this scenario, suggesting that governments had been taking the extraterrestrial hypothesis seriously even when publicly dismissing it. Dr. Jennifer Walsh at the Space Telescope Science Institute captured the broader implications. We're not just looking at first contact, we're looking at evidence that we've been under systematic observation for potentially thousands of years. The timing of 3I, Atlas's arrival 8,000 years ago, coincides with the development of human civilization. This might not be reconnaissance, it might be monitoring. The 17 mini-probes scattered throughout the solar system began immediate systematic exploration activities that demonstrated sophisticated artificial future intelligence. The Mars visitors approached within 50 meters of NASA's Perseverance rover, conducting detailed scans with unknown sensors before retreating to safe distances. They're studying our technology, realized Dr. Amy Chen at JPL. The probes aren't just observing natural phenomena, they're specifically investigating our robotic presence throughout the solar system. The Europa probes descended toward the Moon's icy surface, apparently conducting geological surveys of the subsurface ocean that might harbor life. But their approach patterns suggested they weren't just looking for generic life signs. They were specifically investigating the regions where Earth-based telescopes had detected the most promising biosignatures. Most unsettling were the Earth-monitoring probes that had established permanent observation posts at the Lagrange points. Within days of arrival, these objects deployed solar panel arrays and communication dishes that clearly indicated long-term surveillance missions. "We're seeing infrastructure deployment," Dr. Williams reported to Pentagon leadership. "These aren't simple probes. They're establishing permanent monitoring stations with power generation and communication capabilities designed to operate for decades." Radio intercepts, suggested the probes, were transmitting regular reports to multiple destinations beyond the solar system. The Pol-Red signals used modulation techniques unknown to human technology, with information density that exceeded our best compression algorithms by factors of hundreds. Whatever intelligence created these devices possesses communication technology that makes our most advanced systems look primitive, Dr. Rodriguez analyzed. They're transmitting the equivalent of libraries worth of data in seconds-long bursts. The psychological impact on human civilization proved as dramatic as the technological implications. Religious leaders worldwide grappled with cosmologies that hadn't accounted for active extraterrestrial intelligence. The Vatican issued statements about brothers among the stars. Islamic scholars debated whether alien intelligences fell under divine creation. Buddhist and Hindu traditions, already comfortable with multiple inhabited worlds, found their worldviews surprisingly relevant. Scientific communities faced the humbling realization that human understanding of the universe had been fundamentally incomplete. Decades of SETI research had focused on detecting radio signals from distant civilizations, never considering that those civilizations might be actively studying us with physical probes. "We've been looking for cosmic neighbors while they've been watching us from the backyard," Dr. Elena Vasquez observed with characteristic directness. New space programs emerged focused entirely on developing capabilities for interacting with, or defending against, technological visitors. The global space surveillance network expanded from monitoring routine debris to tracking objects as small as basketballs throughout the solar system. Early warning systems evolved from simple detection to threat assessment, attempting to distinguish between natural phenomena and artificial visitors. New protocols emerged for investigating anomalous objects before they could deploy surprise payloads throughout the solar system. Perhaps most significantly, humanity began its transformation from a single-planet species into a cosmic-aware civilization. The knowledge that we live under active observation by technological intelligences from other star systems fundamentally altered our relationship with space exploration, planetary defense, and our long-term survival as a species. The confirmation that 3I Atlas was artificial technology changed humanity overnight. Not gradually, not subtly, but with the sudden finality of a switch being flipped from alone to observed. Tomorrow, in our final chapter, we'll explore how this revelation reshaped human civilization and what it means for our future as we learn to navigate relationships with intelligences that have been watching us far longer than we have been watching them. Hey there, and welcome to our final chapter together. What I'm about to share with you isn't science fiction, TU. It's the new reality that humanity has been learning to navigate since that extraordinary day when 3I Atlas revealed its true nature. The confirmation that 3I Atlas was artificial technology changed humanity overnight. Not gradually, not subtly, but with the sudden finality of a switch being flipped from alone to observed. Within weeks of the perihelion revelation, every major nation had activated emergency protocols that most citizens didn't even know existed. The speed of these responses revealed something that shocked many observers. Our governments had been quietly preparing for this possibility far longer than anyone realized. The United States established the Department of Cosmic Security, a new cabinet-level agency with unlimited black budget funding and authority that superseded traditional intelligence organizations. China launched the Interstellar Monitoring Initiative, mobilizing their entire space program toward detecting and analyzing extraterrestrial technology. The European Union created the Extraterrestrial Intelligence Response Center, coordinating efforts across 27 nations with unprecedented efficiency. Russia activated something called the Strategic Space Defense Command, which apparently had been in development since the Cold War. Even smaller nations scrambled to establish cosmic awareness programs, recognizing that the new reality affected everyone on Earth equally. But here's what struck me most about the governmental responses. They weren't panicked or chaotic. These were carefully planned, methodical implementations of strategies that had clearly been developed over years or even decades. It suggested that while the public was surprised by 3I Atlas, people in positions of power had been taking the extraterrestrial hypothesis seriously for much longer than they'd ever admitted. Dr. Patricia Williams, who found herself heading the new U.S. cosmic security efforts, put it bluntly, "We've been planning for this scenario since the 1960s. What surprised us wasn't that it happened. It was how sophisticated the technology turned out to be. The 17 mini-probes scattered throughout the solar system became humanity's first ongoing interaction with extraterrestrial intelligence, and the experience was both fascinating and deeply unsettling. The probes studying Mars approached NASA's Perseverance rover multiple times, conducting detailed scans with sensors that operated in frequencies we'd never seen before. But they maintained careful distances, never interfering with the rover's operations or attempting direct contact. It's like being studied by a scientist who's careful not to disturb the experiment, Dr. Amy Chen observed from JPL. They're clearly interested in our technology, but they're maintaining professional distance. The Europa probes descended toward Jupiter's moon with surgical precision, targeting the exact regions where Earth-based telescopes had detected the most promising signs of subsurface life. But their approach patterns suggested they weren't just looking for generic biosignatures, NIR, were specifically investigating the areas we found most interesting. They know what we know, realized Dr. Elena Rodriguez. These probes are following up on our research, investigating the same locations we've identified as potentially harboring life. They're building on our scientific discoveries. Most concerning were the Earth monitoring probes that had established permanent observation posts at the L4 and L5 Lagrange points. These weren't simple satellites. They were sophisticated monitoring stations that deployed infrastructure clearly designed for long-term operations. Solar panel arrays the size of football fields unfurled to provide power. communication dishes oriented toward multiple star systems began transmitting regular reports. Most unnervingly, the stations deployed what appeared to be defensive systems, structures that could deflect incoming objects or generate protective fields. "We're looking at permanent bases," Dr. Williams reported to a classified congressional briefing. "These aren't temporary research outposts. They're establishing long-term presence in our solar system." The communication intercepts provided the most chilling insights into what we were dealing with. The signals transmitted by the monitoring stations used compression algorithms that packed incredible amounts of information into brief bursts. When our best cryptographers analyzed the data density, they realized each transmission contained the equivalent of entire libraries worth of information. "They're sending comprehensive reports about everything," Dr. Rodriguez calculated. "Atmospheric changes, technological developments, population movements, electromagnetic signatures from our cities. We're under total surveillance." But the most disturbing aspect wasn't the surveillance itself, it was the efficiency. The probe network had established complete monitoring coverage of the inner solar system using just 17 objects. The coordination required for such efficiency suggested intelligence far beyond human capabilities. "We're dealing with minds that think on scales we can barely comprehend," Dr. Jennifer Walsh observed. "The level of planning and coordination required for this operation suggests intelligence that's been studying interstellar logistics for centuries or millennia." The psychological impact on human civilization proved as significant as the technological revelations. Religions worldwide grappled with cosmologies that hadn't accounted for active extraterrestrial intelligence operating in our solar system. The Vatican issued carefully worded statements about divine creation extending beyond Earth, while Islamic scholars debated whether alien intelligences fell under the concept of God's infinite creation. Protestant denominations split between those who saw extraterrestrial life as confirmation of God's vast universe, and those who viewed it as a theological challenge requiring new interpretation. Buddhist and Hindu traditions found their existing frameworks surprisingly applicable, as both had always assumed multiple inhabited worlds throughout the cosmos. The Dalai Lama issued a statement that simply said, "We welcome our cosmic neighbors and hope for peaceful coexistence." But the religious implications paled compared to the scientific revolution. Decades of SETI research had focused on detecting radio signals from distant civilizations, operating under the assumption that we would make contact through electromagnetic communication across interstellar distances. The 3I Atlas incident revealed that assumption to be completely wrong. Advanced civilizations apparently prefer physical reconnaissance to radio communication, using sophisticated probes to study other worlds directly, rather than broadcasting their presence across the galaxy. "We've been sitting by the phone waiting for a call," Dr. Elena Vasquez observed, "while they've been studying us through the window." This realization forced a complete overhaul of search strategies. Instead of listening for signals from space, humanity began developing technologies to detect artificial objects moving through the solar system. The focus shifted from communication to observation, from passive listening to active detection. New space programs emerged with unprecedented funding and international cooperation. The Global Space Surveillance Network expanded its mission from tracking space debris to identifying potential artificial visitors. Arrays of new telescopes specifically designed to detect fast-moving objects began construction on every continent. Early warning systems evolved from simple asteroid detection to comprehensive threat assessment. New protocols emerged for investigating anomalous objects before they could deploy surprise payloads throughout the solar system. The most ambitious project was the Deep Space Monitor Network, AG, a constellation of space-based sensors positioned throughout the outer solar system to provide years of advance warning for future interstellar visitors. The network would cost over $200 billion and require cooperation between nations that had barely spoken to each other just months earlier. The 3I Atlas incident taught us that our cosmic neighborhood is far more active than we realized, explained Dr. Michael Chen, who found himself coordinating the international effort. We need to know what's coming long before it reaches the inner solar system. But perhaps the most profound change was philosophical. Humanity began its transformation from a single-planet species into a cosmic-aware civilization. The knowledge that we live under, active observation by technological intelligences from other star systems, fundamentally altered our relationship with space exploration, technology development, and our long-term survival strategy. Every major decision now included cosmic implications. Space missions were planned with the assumption that they would be monitored by alien intelligence. Technology development proceeded with awareness that our capabilities were being assessed by observers whose intentions remained unknown. "We're no longer developing in isolation, Doctor," Williams noted. "Every advance we make, every capability we develop, is being evaluated by intelligences that have been watching us evolve for millennia." The probe network established that interstellar visitors weren't rare cosmic accidents but regular occurrences in a galaxy filled with traveling intelligences. Computer models suggested that dozens or hundreds of similar probes might have visited our solar system throughout human history, most remaining undetected due to our limited observational capabilities. 3I. Atlas might be just the first one we were advanced enough to notice. "Doctor," Rodriguez realized, "there could have been dozens of others that came and went without us ever knowing." This possibility led to exhaustive searches through historical astronomical records, looking for objects that might have been artificial visitors misidentified as natural phenomena. Several candidates emerged, objects with unusual characteristics that had been dismissed as measurement errors or natural anomalies. The search extended to archaeological records, looking for ancient observations of unusual celestial objects that might have been probes rather than comets or meteors. Some researchers began investigating historical events that might have been influenced by extraterrestrial observation or intervention. As I'm recording this, 6 months after the perihelion revelation, humanity continues adapting to the new cosmic reality. The monitoring stations at the Lagrange points maintain their silent watch, transmitting regular reports to destinations we can only guess at. The probes throughout the solar system continue their systematic surveys, studying everything from Martian geology to asteroid belt composition. We've attempted communication with the monitoring stations, broadcasting mathematical sequences, scientific data, even simple greetings. The probes acknowledge our transmissions. We know they're receiving them because their antenna systems orient toward Earth whenever we broadcast. But they don't respond. They're maintaining professional distance, Doctor, Chen observed, like scientists studying wildlife who don't want to interfere with natural behavior. The question that keeps everyone awake at night is simple. What happens next? Are we being evaluated for some purpose? Are the probe reports leading to decisions about humanity's future? Are we considered a threat to be monitored, a curiosity to be studied, or potential allies to be approached when we reach sufficient technological maturity? Dr. Avi Loeb, whose controversial analysis had been vindicated by events, offered a sobering perspective. We're probably not the first civilization they've studied, and we won't be the last. The question is whether we pass whatever evaluation criteria they're using. The 3I Atlas incident established one truth beyond doubt. We are no longer alone, we are no longer unobserved, and we are no longer the only intelligence active in our cosmic neighborhood. The universe revealed by 3I Atlas is simultaneously more wondrous and more dangerous than we ever imagined. Our survival as a species now depends on learning to navigate relationships with intelligences that have been watching us far longer than we have been watching them. The cosmic playground that Dr. Loeb described isn't empty after all. It's full of older children who have been playing there much longer than we have. The story of 3I Atlas isn't really ending, it's just beginning. Because now that we know we're being watched, the real question becomes, what are we going to do about it? Thanks for joining me on this incredible journey through one of the most significant discoveries in human history. The universe just got a whole lot more interesting, and a fairy AT, a whole lot more complicated. But one thing's for certain, we're living in the most extraordinary time in human history, when our species finally learned that we're not alone among the stars. Until next time, keep looking up. You never know what might be looking back.